Welcome everyone to ccqMap.com. Thank you so much for tuning in again. This is the part 4 of the full tutorial of QMap Standard. In this episode, I am going to walk you through one of the major functions in QMap Standard, the linear analysis and extraction tool. So without further ado, let's jump into today's tutorial. Let's load an image which consists of multiple distinguishing colors. First, let me explain how this tool works. The linear analysis and extraction tool is designed to extract a certain feature from an image. When we are analyzing an image, we have to ask the following questions. Can we extract out the information that we want? How do we extract out the information that we want? What is the extraction accuracy? How do we verify the result? How fast is the extraction process? And the linear analysis and extraction tool has answers for all these questions. But first, let me tell you what a feature means. As you can see in the picture, we have certain landscapes such as forest and vegetation, mountains and rocks, sea or ocean. Each landscape can be considered as a feature. So a feature is essentially a combination of feature colors. The idea of a feature is very subjective. It can be a certain landscape, a certain color, or a certain type of building, or a certain type of organ in a medical image, and etc. So the idea of a feature is solely based on the user's definition. Thus, back to our original questions, how do we locate, extract, and separate and classify your desired feature? Let me explain to you with one example. In this demonstration, let's say our objective is to extract all the vegetation in this image. In other words, we define all the forest as the desired feature. Now let's look at the linear analysis and extraction window, and I will explain the user interface and information extraction sequence. The first step of the extraction process is to visually inspect and observe the whole picture carefully. In this case, we need to identify all the forest. So as you can see, at the right side of the picture is all ocean and sea, so we have to zoom in and take a better look at it. So we have a lot of forest coverage at the coastal area here, and in between we have a lot of rocks here and some rocks here, mountains and rocks here. So this area, the forest is combined with the rock, and it's mostly allocated at the coastal area. At the same time, we can always zoom in and out or pan to navigate. When we zoom in, we can have a better look at this picture, so it's more accurate for you to visually identify your feature. Step 2 is to select at least 6 points by right-clicking from your visually identified forest. We call these points sample points. Let's do that now. So from this area, we can see it's full of forest and vegetation. So we can right click and select 6 points. But be very careful not to select irrelevant points. So we have to zoom in to make sure these points are really vegetations. So don't select anything yellow here because visually it's rock. So we can click somewhere like here. This concept is to use known information to deduce and extract unknown information. If you feel that sample point's crosshair is too thin or small, you can adjust the crosshair size by clicking the drop-down menu. I think 40 is just nice. After we select these sample points, they will be shown in this yellow area with their details. So we have at the left side we have the sample points numbers, and then we have their RGB red, green, and blue value, and their location X, Y located at this image, and the file name. Do take note, one particular feature can have different colors. For example, as you can see, the vegetations here, the color is much lighter than the vegetation at this area. So it is for the same material, which is the forest, but they have different colors. So we have to include these into our selection too. After we selected the sample points, we can click the test button instantly to check the result. As you can see here, not all the vegetation has been extracted, especially this area, the darker colored area here. We can always add or subtract point from the selection too. Then we can check the result again. This time is much better. When we use this linear analysis tool, we will be constantly using the test button to continuously check the extraction result. I want to mention here that QMap extracts information based on window checking mechanism. It means QMap only checks what it is displayed in the window. So if you zoom into a certain section of the original picture, QMap only extract information and present the result on that area. For example, I will zoom in again and click test again. As you can see, the result is only shown on the zoomed in area. And when you zoom out, QMap will perform the extraction for the entire image. Let me demonstrate again. The advantage of this mechanism is that it will reduce the computer's CPU load when you are processing a high quality image. So it will not slow your computer down, thus resulting in a faster workflow.